Comparative Analysis of Space Exploration Initiatives, Comparing NASA ESA and China's Mars Missions by 2026. Introduction. The landscape of space exploration is undergoing a significant transformation as major space agencies and nations embark on ambitious Mars missions. By 2026, NASA United States ESA European Space Agency and CNSA China National Space Administration will lead these efforts, each with unique strategies and technologies. This report provides a comprehensive analysis of their missions' technological advancements and collaborative efforts, highlighting the competitive dynamics shaping the future of space exploration. Key missions and developments by 2026. NASA's initiatives. 1. Artemis program. NASA's Artemis program is a cornerstone of its lunar exploration strategy, aiming to establish a sustainable human presence on the Moon by the late 2020s. This program includes various robotic and crewed missions with critical milestones set for the years leading up to 2026. Artemis serves as a preparatory step for future Mars missions, enabling the testing of technologies and systems necessary for long-duration space travel. 2. Europa Clipper. Scheduled for launch in 2025, the Europa Clipper mission will primarily focus on exploring Jupiter's moon Europa, but it will also conduct a gravity assist maneuver at Mars. This flyby will provide valuable data about Martian atmospheric conditions and surface features, enhancing our understanding of the planet as a potential site for future human exploration. ESA's contributions. 1. SpaceRider. The SpaceRider is an uncrewed reusable spaceplane set to make its maiden flight in late 2025. This versatile platform is designed for multiple missions, including satellite deployment, in-orbit research, and technology testing for future exploration endeavors. Its reusability reflects ESA's commitment to sustainable and cost-effective space operations. 2. Hera mission. Scheduled for launch in 2025, the Hera mission aims to study Mars moons, particularly Deimos. This mission will utilize a gravity assist maneuver at Mars, allowing it to gather crucial data about the composition and origin of these moons, which is essential for refining navigation techniques for future Mars missions. China's ambitions. 1. Tianwen-2. Launching in 2025, Tianwen-2 is China's follow-up mission to the successful Tianwen-1. This mission will focus on collecting samples from a near-Earth asteroid and conducting observations of a comet. Tianwen-2 signifies China's growing capabilities in deep space exploration and reflects its ambition to become a leader in planetary science. Technological innovations. Technological advancements are at the forefront of these space missions, with each agency focusing on innovations that enhance exploration capabilities. Key developments include reusable spacecraft. Both NASA and ESA are emphasizing reusability in their spacecraft designs. NASA's Artemis program is developing systems for reusable lunar landers, while ESA's SpaceRider will serve multiple missions, reducing costs and increasing operational efficiency. Propellant transfer technologies. SpaceX plans to demonstrate in-space propellant transfer in 2025, a breakthrough that could revolutionize long-duration missions by allowing spacecraft to refuel in orbit. This technology is crucial for upcoming Mars missions, enabling larger payloads and extended mission durations. Environmentally friendly propulsion. The industry is increasingly adopting cleaner propulsion systems. ESA is exploring hybrid propulsion technologies, while companies like Rocket Lab are designing rockets that utilize biopropane fuel, minimizing carbon emissions. Common themes. Across the missions planned by NASA, ESA, and China, several common themes emerge: sustainability and reusability. Each agency is prioritizing sustainability and reusability in its missions. This shift is essential for addressing the challenges of space debris and orbital congestion, particularly with the increasing number of satellite constellations being deployed. International collaboration. International cooperation is becoming more critical in the context of space exploration. All three agencies are exploring partnerships with private companies and other nations to share resources, expertise, and technology. This collaborative approach enhances mission success rates and reduces costs. Focus on lunar exploration as a stepping stone. Lunar exploration is seen as a vital precursor to Mars missions. NASA's Artemis program aims to establish sustainable lunar operations, while ESA's initiatives complement these efforts by focusing on technical advancements that can be applied to Mars exploration. Differences among sources. While the overarching themes highlight similarities among the agencies, differences in focus and approach can be observed. NASA emphasizes the Artemis program as foundational for human exploration, underlining its critical role in preparing for Mars missions. ESA highlights the importance of the Hera mission for understanding Martian moons, presenting it as a key element for future navigation and exploration techniques. China's Tianwen-2 is distinctly framed as a demonstration of its emerging capabilities in deep space exploration, contrasting with the more established frameworks of NASA and ESA. Timeline of key events. 2025. January, ESA's Bepi-Colombo conducts a gravity assist at Mercury. March, NASA's Europa Clipper performs a gravity assist at Mars. Q3, ESA's Space Rider has its maiden flight. April, NASA's Lucy mission performs a flyby of asteroid 52246 Donald Johanson. Launch of Tianwen-2 to study an asteroid and a comet. 2026. Continued development and evaluation of technologies for sustainable lunar and Martian exploration, with missions advancing toward establishing permanent human habitats. Conclusion. The competitive landscape of space exploration initiatives by 2026 reveals a dynamic interplay of technological innovation, international collaboration, and sustainability efforts. NASA, ESA, and China are poised to make significant advancements in their respective missions, each contributing to a shared vision for the future of humanity in space. The emphasis on reusable technology, sustainable practices, and collaborative partnerships will define the next era of exploration, paving the way for long-term human presence on Mars and beyond. Through these efforts, we are entering an exciting chapter of space exploration that promises to expand our understanding of the universe and our place within it. As these missions unfold, they will shape the trajectory of global space exploration, fostering a spirit of cooperation and shared discovery among nations. The competitive analysis of space exploration initiatives reveals several counterintuitive insights regarding the roles and strategies of NASA, ESA, and China in their Mars missions by 2026. 1. Perception of leadership. While NASA has historically been viewed as the leader in space exploration, the analysis suggests that ESA and China's space ambitions are rapidly closing the gap. China's Tianwen-2 mission, for instance, is positioned not just as a competitor but as a demonstration of its growing capabilities in deep space exploration, which may challenge the long-held status of NASA as the preeminent space agency. 2. Sustainability focus. There is a widespread assumption that sustainability in space exploration is primarily a concern of environmentalists. However, all three agencies, NASA, ESA, and China, are prioritizing sustainability not just for ecological reasons but as a critical strategy for long-term viability in space. This underscores a broader recognition that sustainable practices are essential for maintaining operational capabilities and reducing costs, which may not align with the traditional view that space exploration is primarily driven by scientific discovery. 3. International collaboration. The expectation might be that competition leads to isolationism among spacefaring nations. Yet the competitive landscape shows an increasing trend towards collaboration. For example, ESA's Hera mission and China's Tianwen-2 indicate that even amidst competition there is a shared understanding of the benefits of cooperative efforts. This collaboration is essential for addressing common challenges such as space debris and technological advancements, which contradicts the notion that competition would inhibit partnerships. For the technological innovations as equalizers, the narrative often suggests that only established agencies like NASA possess the technological prowess necessary for deep space missions. However, the advancements being made by private companies like SpaceX and the innovative strategies of emerging players such as China demonstrate that technological innovations are democratizing space exploration. This challenges the conventional wisdom that only traditional government agencies can lead in this domain. 5. Role of private sector. There is a common belief that government agencies will primarily drive space exploration initiatives. However, the analysis reveals that private companies are increasingly integral to national space strategies. SpaceX, Blue Origin, and others are not only supporting missions but are pioneering technologies that may redefine operational norms in space. This shift indicates a move towards a model where the private sector plays a critical role, which contrasts with earlier assumptions of a government-dominated landscape. 6. Mars as a priority. The traditional view holds that lunar missions are stepping stones to Mars exploration. However, the competitive analysis shows that all three agencies are simultaneously pursuing Mars and lunar missions, suggesting a more integrated approach to exploration than previously thought. This indicates a realization that advancements in one area, whether lunar or Martian, can directly enhance capabilities in the other, challenging the linear progression narrative. 7. Public interest in funding dynamics. It is often assumed that public interest in space exploration is primarily driven by high-profile missions like manned moon landings or Mars explorations. However, the analysis indicates that sustainability efforts and orbital infrastructure developments are garnering significant attention and funding. This shift reflects a more nuanced understanding of what captures public interest, suggesting that the focus on long-term sustainability may be as compelling as the allure of exploration itself. 8. Space debris concerns. The expectation might be that increased activity in space will naturally lead to greater risks of collision and debris. While this is true, the proactive measures being taken by all agencies, including innovations in debris management and mitigation strategies, reveal a counterintuitive approach. Rather than waiting for a crisis, these agencies are actively working to address potential issues before they escalate, demonstrating a level of foresight that contrasts with the reactive tendencies often associated with space operations. In summary, the competitive analysis of NASA, ESA, and China's Mars missions by 2026 uncovers several counterintuitive insights that challenge traditional perceptions of leadership, sustainability, collaboration, and the role of the private sector in space exploration. These insights suggest a rapidly evolving landscape where innovation, partnership, and a focus on long-term viability are reshaping the future of humanity's endeavors in space. In the competitive landscape of space exploration initiatives by 2026, certain critical aspects of the ongoing developments involving NASA, the European Space Agency ESA, and China's Mars missions could easily be overlooked. Highlighting these aspects along with their significance provides a deeper understanding of the evolving dynamics in global space exploration. 1. Technological interdependencies and innovations. A key area that may not receive adequate attention is the interdependence of technologies being developed across different agencies and their potential collaborative impact. For instance, while NASA's Artemis program focuses on lunar habitation as a precursor for Mars missions, it also sets the stage for ESA's SpaceRider and China's Tianwen-2 missions to leverage the advancements in life support, habitat design, and propulsion technologies. Significance. This interconnectedness underscores the idea that success in space exploration is not solely dependent on individual agency capabilities but on a broader ecosystem of technological advancements. As these technologies mature, they can be adapted and utilized by different missions, creating a more integrated approach to exploration that could expedite timelines and reduce costs. 2. Sustainability beyond buzzwords. While sustainability is frequently mentioned, the practical implementation of sustainable practices in space missions is another aspect that may be overlooked. The focus on reusable spacecraft such as ESA's SpaceRider and SpaceX's advancements is not just about cost reduction but also about minimizing the environmental impact of space operations. Furthermore, the adoption of biofuels and hybrid propulsion systems represents a significant shift in how space agencies are approaching their ecological footprints. Significance: the commitment to sustainability in space exploration reflects a growing awareness of the long-term implications of human activities beyond Earth. By prioritizing sustainable practices now, these agencies set a precedent for future missions, ensuring that space remains accessible and safe for generations to come. This proactive approach could also influence policies and practices in other high-tech industries. Promoting a culture of sustainability. 3. Data sharing and international collaboration. The competitive nature of space missions often overshadows the collaborative efforts that are also taking place. For example, while each agency is racing to establish its presence on Mars, there are numerous partnerships and data sharing agreements that enhance the scientific value of the missions being undertaken. ESA's Hera mission, which is set to gather insights on Martian moons, exemplifies this collaborative spirit, as findings will be shared across agencies including NASA and China's CNSA. Significance: the collaborative sharing of data and findings fosters a collective advancement in planetary science. This not only maximizes the scientific output but also enhances global cooperation in space exploration, which is essential for tackling challenges like space debris and planetary defense. This collaborative framework could serve as a model for addressing broader international issues beyond space exploration. 4. Private sector's role in space exploration. The increasing involvement of private companies in space exploration is often highlighted, but the extent to which they are shaping the landscape is frequently underestimated. Companies like SpaceX and Blue Origin are not only launching missions but are also driving innovation in launch systems, spacecraft design, and orbital infrastructure. The planned demonstrations by SpaceX regarding propellant transfer and Blue Origin's One Malawian Kwacha lunar lander are notable examples of how private entities are pushing the boundaries of what is possible. Significance: the private sector's role signifies a paradigm shift in space exploration, where large-scale projects can be executed more efficiently and innovatively. This trend towards privatization can lead to a more dynamic and responsive space economy, with private companies complementing the efforts of national agencies rather than simply competing against them. The synergy between public and private sectors can potentially accelerate human exploration of Mars and beyond. 5. The impact of AI and automation. The increasing integration of artificial intelligence, AI, and automation in space missions is another area that warrants closer examination. AI is becoming a cornerstone for mission planning, data analysis, and autonomous operations in space. For instance, the use of AI in China's Tianwen-2 mission for real-time data analysis and in ESA's JUICE mission for navigation and hazard detection could drastically enhance mission success rates. Significance: the application of AI not only streamlines operations but also enables more sophisticated analyses of data collected during missions. This technological advancement can lead to new discoveries and a more profound understanding of planetary systems, thus enhancing the scientific return on investment for these missions. Furthermore, AI can play a pivotal role in long-term human presence in space, optimizing life support systems and resources utilization. 6. Space debris and long-term viability. While the excitement surrounding Mars missions captivates attention, the issue of space debris and its management is often sidelined. The growing number of satellites and missions increases the risk of collisions and the generation of debris, which poses a significant threat to future space exploration activities. Initiatives focused on debris mitigation and sustainable practices are critical for ensuring the long-term viability of low Earth orbit and beyond. Significance: addressing space debris is not just an environmental concern, it is a foundational aspect of safe and sustainable exploration. By prioritizing debris management now, space agencies and companies can protect their investments and ensure that future missions can be conducted safely. This proactive approach is crucial for maintaining the integrity of space as a resource for humanity. Conclusion: In summary, the competitive analysis of NASA, ESA, and China's Mars missions by 2026 reveals several critical elements that are often overlooked. From technological interdependencies and sustainability practices to the role of private entities and the integration of AI. These aspects are shaping the future of space exploration. Understanding their significance offers a more nuanced perspective on the collaborative and innovative landscape that defines humanity's pursuit of knowledge beyond Earth. As we move closer to an era of sustained human presence on Mars and beyond, these factors will play a pivotal role in determining the success and sustainability of our endeavors in space. 1. Technological innovations and sustainability efforts. The content emphasizes the critical role of technological advancements in space exploration, particularly regarding sustainability. Innovations like reusable spacecraft, ESA's SpaceRider, and SpaceX's Starship hybrid propulsion systems, and environmentally friendly fuels are shaping the future of space missions. These technologies not only enhance mission efficiency but also address the pressing issue of space debris and environmental impacts, reflecting a commitment to sustainable exploration. An in-depth analysis could explore how these innovations are being implemented, their potential long-term benefits, and the challenges associated with scaling these technologies for future missions. 2. The competitive landscape among NASA, ESA, and China. The evolving competitive dynamics among NASA, ESA, and China's space agencies is a focal point of the discussion. Each agency is pursuing distinct yet complementary missions that contribute to a broader understanding of Mars and beyond. NASA's Artemis program lays the foundation for lunar and Martian exploration. ESA's Hera mission focuses on understanding Martian moons, and China's Tianwen-2 showcases its growing capabilities in deep space exploration. A thorough examination of each agency's strategic priorities, funding models, and international collaborations can provide insights into how these competitive efforts may shape the future of global space exploration. 3. International collaboration and public-private partnerships. The content highlights the importance of international cooperation and public-private partnerships in advancing space exploration objectives. The integration of efforts from various countries and private entities allows for shared resources, expertise, and technological advancements. For example, missions like ESA's JUICE and China's Tianwen-2 demonstrate cross-border collaboration aimed at achieving scientific goals. A detailed discussion could analyze specific partnerships, their impacts on mission success, and how they can be leveraged to tackle common challenges such as orbital congestion and space debris management. For future challenges and opportunities in space exploration. As space missions become more ambitious, the content outlines significant challenges including funding constraints, technological hurdles, and the risks associated with satellite megaconstellations. These challenges necessitate careful planning and innovative solutions to ensure the sustainability of space activities. Moreover, opportunities for global cooperation and the integration of AI in mission planning and execution present new avenues for enhancing exploration capabilities. An in-depth analysis could delve into how these challenges and opportunities are interlinked, the strategies being employed to address them, and the potential implications for the future of human presence in space. These points offer a comprehensive framework for understanding the complexities and advancements in space exploration initiatives by 2026, providing a basis for further discussion and analysis. 1. The space race 1957 to 1975. This historical period marked a competition between the United States and the Soviet Union for dominance in space exploration. The launch of the Soviet satellite Sputnik in 1957 ignited the race, leading to significant milestones including the first human in space, Yuri Gagarin, in 1961, and the Apollo 11 moon landing in 1969. Both nations invested heavily in technology and innovation, leading to advancements that shaped future space exploration. 2. Mars Exploration Program 1960s-present. The various missions to Mars, starting with the Mariner program in the 1960s, set the stage for contemporary exploration efforts. NASA's Viking 1 and 2 missions in the 1970s were the first successful landers on Mars, providing critical data about the planet's surface and atmosphere. This long-standing commitment to Mars exploration has paved the way for current missions including the Perseverance rover and upcoming initiatives from ESA and China. 3. International Space Station 1998-present. The ISS represents one of the most significant examples of international collaboration in space exploration. Launched in 1998, it involves multiple countries including the United States, Russia, Europe, Japan, and Canada. The station serves as a platform for scientific research and technological advancements, fostering cooperation among nations while addressing challenges in long-term human habitation in space, which is crucial for future Mars missions. Future outlook: competitive analysis of space exploration initiatives by 2026. As we advance toward 2026, the competitive landscape of international space exploration is set to evolve significantly, particularly with key Mars missions from NASA, the European Space Agency, ESA, and China. The interplay of technological innovation, international collaboration, and sustainability will shape the future of humanity's endeavors beyond Earth. Key missions and developments by 2026. 1. NASA's initiatives. Artemis program. NASA's commitment to establishing a sustainable human presence on the Moon will serve as a critical precursor for future Mars exploration. By 2026, the program aims to achieve significant milestones including advancing lunar habitat technologies and preparing for crewed Mars missions. Mars Sample Return MSR, set for late 2020s, this mission will collect samples from Mars, demonstrating the U.S.'s commitment to returning Martian materials for analysis, thereby enhancing our understanding of potential life on Mars. 2. ESA's contributions. Hera mission, slated for launch in 2025. Hera will gather vital data regarding Mars moons Deimos and Phobos. This mission is crucial for navigation techniques and may include potential future human interactions with these moons, facilitating deeper exploration of the Martian system. ExoMars rover. The rover, developed in collaboration with Roscosmos, aims to search for biosignatures on Mars, providing significant insights into the planet's history and potential for life. 3. China's ambitions. Tianwen-2, launching in 2025. This mission will collect samples from asteroids and conduct observations of comets. China's rapid advancements in deep space exploration reflect its growing capabilities and ambitions on a global scale. Technological innovations shaping the future. The space exploration sector is experiencing rapid technological advancements that enhance mission capabilities. Key developments include reusable launch systems. Innovations in reusable rockets like SpaceX's Falcon 9 and ESA's SpaceRider will reduce the costs associated with launching payloads into space. This trend is critical for sustained exploration efforts. In-space propellant transfer. SpaceX's demonstration of propellant transfer in orbit will enable longer missions to Mars by allowing spacecraft to refuel, thus reducing the need for massive initial payloads. Hybrid propulsion systems. The adoption of environmentally friendly propulsion systems is gaining momentum, with companies focusing on reducing the carbon footprint of space activities. Sustainability and environmental considerations. As space agencies prepare for deeper exploration, sustainability is becoming a priority. Initiatives include debris mitigation strategies. With the increasing number of satellites and missions, addressing space debris is vital. International collaboration will be necessary to establish guidelines for debris management and end-of-life disposal for satellites. Green propulsion technologies. Adoption of biofuels and other sustainable technologies will be crucial in minimizing the environmental impact of space exploration. International collaboration and competition. The competitive nature of space exploration fosters innovation but also necessitates collaboration. By 2026, the landscape will likely include joint missions. The potential for collaborative missions like ESA's JUICE and NASA's Mars Sample Return exemplifies how international partnerships can enhance scientific outcomes while sharing costs and expertise. Public-private partnerships.
The involvement of private companies in space exploration, such as SpaceX and Blue Origin, will continue to grow, with these entities often partnering with national agencies to achieve ambitious goals. Challenges and opportunities ahead.
While the future of space exploration is promising, it is not without challenges. Funding constraints. Sustainable funding remains a significant challenge for national space agencies. Balancing budget constraints while pursuing ambitious missions will require innovative financial models and partnerships. Technological hurdles. Developing reliable technologies for long-duration space travel, particularly for Mars missions, will require continued investment in research and development.
Conclusion.
By 2026, the competitive landscape of space exploration will be characterized by bold missions, technological innovations, and an emphasis on sustainability.
NASA, ESA,
and China will each play critical roles in advancing our understanding of Mars and beyond. The future of space exploration will depend on fostering international cooperation, addressing sustainability challenges, and leveraging technological advancements to ensure a responsible and ambitious presence in space.
The stage is set for an era of exploration that could redefine humanity's place in the cosmos.